AIN 710 Course Reflection. AI Foundations and Evolution. When I began AIN 710, I thought my final paper would focus on building an AI solution. What I didn't expect was that it would evolve into something much more foundational, a structured framework for governing AI, similar to how clinical trials are governed in healthcare. Over the course of this class, my thinking shifted. I moved from focusing on algorithms to focusing on architecture, from model selection to system design. And that evolution is what I want to reflect on. I want to explore the evolution of my final project. My project began with a healthcare interoperability problem, specifically how fall detection systems operate as isolated signals rather than part of a longitudinal, governed clinical intelligence system. At first, my thinking centered on machine learning models. Which algorithm should I use? Would deep learning add value? How complex should the model be? But as the milestones progressed, I began asking different questions. Instead of asking, how powerful can the model be? I started asking, how structured is the system around it? That shift led to three major areas of evolution in my final paper. First, schema-driven AI. Second, explainable AI as an architectural requirement. And third, the development of an AI governance framework modeled after a trial management system. Let me take a few moments and talk about the impact of schema-driven AI during this course. One of the most powerful technical explorations for me was incorporating structured schemas into AI workflows. In my AI coworker repository, I deliberately injected strict JSON schemas into every LLM interaction. Rather than relying on free-form prompting, I required structured outputs with defined fields, required properties, and restricted additional attributes. Why did this matter? Because AI becomes more reliable when it operates within structured constraints. Schemas improve traceability, they reduce ambiguity, and they enable deterministic chaining between AI steps. And they support auditability. That experience directly influenced my final paper. I realized that interoperability is not just about APIs, it's about shared schemas and structured data contracts. If we want AI to function responsibly in healthcare or other high-stakes domains, it must operate within defined structural boundaries, not loose narrative outputs. That insight fundamentally reshaped how I framed my project architecture. Next, I want to explore explainable AI as an architectural obligation. Another major shift in my thinking came around explainable AI, or XAI. Early in the course, I viewed explainability as a technical feature, something you add to the model. But over time, I began to see it differently. Explainability is not a feature, it is a system requirement. In my NLP lab repository, I built logging, confidence scores, batch stability testing, and observability directly into the workflow. Every AI interaction is logged, confidence metrics are generated, and label stability is evaluated across multiple runs. This mirrors real-world concerns. How stable are outputs? How reproducible are decisions? And can results be audited? Explainability isn't just about feature importance visualizations. It's about building systems where outputs can be interrogated, traced, and evaluated over time. That perspective shaped how I approached milestone 6. particularly around bias evaluation, oversight, and human-in-the-loop governance. Finally, I want to talk about the idea that surfaced in the final weeks of the course: AI governance modeled like a trial management system. The most important evolution in my thinking came when I stopped viewing AI as a model deployment problem and began viewing it as a governance lifecycle problem. In healthcare, clinical trials are governed by structured systems. There are defined protocols, documentation standards, audit trails, ethical review boards, version control, and change management. Why should AI deployment in high-stakes domains be treated any differently? So in my final paper, I proposed an AI framework modeled after a trial management system, an AI master file concept, a structured lifecycle, including model hypothesis documentation, data lineage tracking, bias and fairness, evaluation checkpoints, versioned deployment protocols, and ongoing monitoring and post-deployment review. In this framework, the specific technique, symbolic AI, machine learning, or deep learning, becomes secondary. Governance becomes primary. That was the intellectual shift. Before concluding this video, I also want to mention the 2 GitHub repositories I developed. To ground the ideas I discussed in practice, I built 2 GitHub repositories during this course. The first, our first AI coworker, demonstrates structured schema, injection, and staged AI roles, analysts and strategists. It shows how structured outputs can feed downstream reasoning in a deterministic, auditable workflow. The second, NLP in the wild, functions as a sentiment and confidence laboratory. It includes batch sentiment testing, confidence metrics, embedding analysis, and structured observability. Together, these projects allowed me to experiment with structured outputs, stability evaluation, and operational transparency. They moved my thinking from theoretical AI to governed AI. Let me conclude by offering constructive course feedback. One aspect of this course that stood out to me was the breakout sessions during the weekly live discussions. Those small group conversations were some of the most engaging and valuable parts of the AIN 710 experience. Being able to connect with classmates, exchange perspectives, and hear how professionals from different industries interpret AI added depth that readings alone cannot provide. AI is evolving rapidly, and dialogue across disciplines is essential. If I could offer one suggestion, it would be to intentionally expand that space, perhaps dedicating 15 to 20 minutes each week, specifically for structured breakout discussion with the professor rotating between groups. More time for active conversation, challenging assumptions, sharing examples, and networking would amplify one of the strongest aspects of the course. For me, these discussions were not just academic exercises, they were collaborative learning experiences. And finally, some closing reflection. When I began AIN 710, I thought AI success meant building powerful models. Now I believe AI success means building governed systems. Schemas before scale, explainability before deployment, frameworks before automation. This course did not just teach techniques, it refined how I think about AI. And that shift from model thinking to system thinking is the most valuable outcome of this experience. Thank you.